Hello there. Today we are going to discuss the confusion matrix in machine learning or in data science. So machine learning is a evaluation matrix where we can determine the accuracy and precision of a machine learning model, like how much he predicted positives and negatives, the model, and were those values actually true or not. So normally you would see an n into n matrix, so n rows and n columns. So right now, as you guys can see that we have 2 into 2 matrix where we have 2 rows and 2 columns. So what are these values? Let's discuss that. So we have some matrix like this one. This matrix can be n into n values. It can increase and decrease. But right now we are assuming that the outcome of the machine learning model was 2 into 2, right? So the confusion matrix was 2 into 2. So for the first first quadrant over here, as you can see this one, we have true positives. So what are true positive? True positives means that the values were true, right? The values were actually true, and the machine learning also predicted that you know what they are true. Like for example, if I say that you know what it is raining outside, and machine learning also predicts that you know what it is raining. So those will be like machine learning is accurate and it predicted correct values, right? Now we have, in simple terms, we can say that the predicted value is positive and the actual value is also positive. So as I give you the example of raining. And next we are going to determine the fourth or the third quadrant, which is true negative, right? So what does true negative means? True negative means that the actual value was negative, was false, and the true value and the predicted value, the machine learning which we predicted, it was also false. So we can say that predicted is negative and the actual value is also negative. Like saying that if I say that, you know what, it is not raining outside, and machine learning also says that, you know what, it is not raining outside. So they both predicted and the actual value both are equal, both are same. So they predicted true negative values. Like saying that as I said, give you the example of the raining. So I also said to machine learning that based on some features, it is not raining outside. And machine learning also predicted that, you know what, it is not raining outside. So that would be true negative values, right? Then we have the false positive values. So what are false positive values? False positive values are basically those values which the machine learning predicted as positive while they were negative, right? So machine learning says that, you know what, they are positive, and I say, you know what, they are false actually. So let's say machine learning says that, you know what, it is raining outside, right? It predicted a positive value. But when I actually see outside, there is no rain. So actually it is false. Machine learning is false. So basically it is a negative kind of aspect of machine learning, which where it predicts negative, or you can say it is an kind of an error in machine learning where it predicts a false positive number or a false positive data. Like as I give you an example, like machine learning model says that it is raining outside while there is no rain. The actual value is false. There is no rain, and machine learning says that you know what, there is rain. So it would be false positive. Then we have false negative. In simple terms, we can say that predicted is positive and the actual value is false. And then we have the last quadrant, which is false negative. So what are false negative? False negative are values which the machine learning predicts as negative, but they are actually true. So what does this mean? Let's say, for example, that machine learning predicts that it is not raining outside, while in actual terms it is raining, right? So that would be false negative. So in simple terms, we can say that predicted is negative, right? Machine learning predicted a negative value while actual value was positive. So I hope it is clear to you guys. And uh, I'm going to give you an example over here. Let's say we have a total data set which is 385 rows, right? We have a data set of 385 rows. So machine learning predicted that 230 rows were or data were true positive, 25 were false positive, then 10 were false negative, and then 120 were true negative. Now, if you want to check if your model is accurate or it is working fine or not, sum these two values, right? Sum these two values. If the sum of these two values is greater than these two, that means that your machine learning is accurate. As we can see over here, that 230 and 120, their sum is greater than these two. So there some these two values sum, this one and this one, 25 and 10 is 35, while these have a greater sum. So whenever you want to predict that whether your machine learning model is accurate or not, just check these two values, right? Check if their sum, these two values, if their sum is greater than these two, right? If that's the case, then your machine learning model is fine and you can deploy it into your whatever wherever you want to try it in your real world scenarios. So basically, there's confusion matrix. You can also check the uh, here is the documentation on the machine learning from the scikit-learn confusion matrix. Um, Basically, it has a lot of you can say a lot of arguments. So it takes a true values, as I said, the true positive values, or you can say those values that were actually correct, or that were actually the actual data, and then the predicted values. So I can show an example over here. I have implemented this Titanic data set model, which you can see in the other videos. I have shared them in my channel. But I'm going to show you that. You know what? Here we can see that we have y test and we have predicted. No, sorry, this one. As we can see that we have this confusion matrix. It is a built-in function from sklearn. Sklearn has its own documentation. I will provide this link. So basically, it takes the true values and the predictive values. These predicted values are the values that were predicted by the model. So model predict those values based on the data. And these y test, these are the true values. So it checks whether true positive, true negatives, false positive, and false negative, and it will give you some metrics like this. And that matrix is basically nothing else but just a quadrant, four quadrants, where we have true positives, false negative, and true negative. So I hope this is all clear to you guys. I will provide the link to this documentation and you can explore it. There are a lot of examples as you can see over here. They have explained it, how it works. As I said that it can be n into n matrix as you can see over here. It's 3 into 3 matrix, 3 into 3 matrix. It can vary based on your data. So it can provide you with 2 into 2 or even n into n. So it can provide you with any kind of output. Right now we have 2 into 2 as you can see here. So that's basically it. That's the confusion matrix. And just remember, as I said, this is the first matrix, first quadrant. This is the second one. This is the third one. And this is the fourth one. So the sum of the first plus the sum of the first and the fourth should be greater than the sum of the two plus three. In order for your machine learning to be accurate and to be valid or to be accepted by real world scenarios, you should have this formula or this method in your mind that your machine learning should provide true positive and true negatives more than the false positive and false negatives. So you should always keep in mind that this scenario should be true. If it's not true, then your machine learning model is failed and you have to process it again and again and train it again on another data and so on. And you can also find some new data on Kaggle and some other websites. But basically, this is all the confusion metrics. And if you have any questions, please let me know. I will provide the link for the confusion metrics documentation in the description. If you have any questions, please let me know. Okay, thanks.